In the previous video, we proved that the entropy is a lower bound on the expected code word length for a symbol code. And I wanted to make a brief video to mention that, in fact, there is another proof of this fact using relative entropy. And we haven't defined relative entropy, but it's this thing. And you can use the fact that relative entropy is non-negative to get a quick, sort of slick proof of this fact. But in order to do that proof, you have to introduce entropy and relative entropy and prove that this is non-negative and stuff. And it's not really clear when you go about doing it that way, what's the point of all this stuff? And so I think it's much more natural to approach it in the way that we did by just saying, okay, we want to minimize our expected code word length, and then just directly attack that problem with calculus and sort of follow in the footsteps of the original discoverers in order to see how the entropy pops out in a very natural way as this lower bound. So I think it's much more natural to approach the problem in this way. And another benefit is that it gives you some more intuition, I think, into what's really going on when you're in deriving this bound. What the sort of minimization problem really sort of looks like. But you should know that there is this alternative sort of easier proof to prove this fact. And maybe we'll do that after we see relative entropy. Maybe we'll do that proof to see how that comes about. Okay, see ya.